Alright guys, we're going to try another video here. This video we are going to look at, if you can see behind me on the board, how to interpret speed and acceleration graphs. Alright. I apologize because it might be a little loud. There's some drums in the band room, out in the hall. Basketball team is running around, yelling and exercising because it's raining. Anyways, so we're going to look at the graphs. I would not be a good weatherman, but we're going to look at the graphs, answer some questions. I made it into a video because some people can go really fast, other people maybe need to go a little slower and take more time, and that's fine. And I'll be around to answer questions for people who need it, so make sure as you're watching it, pause if you don't understand something, ask me, ask somebody around you, don't just watch through the video, okay? Because these graphs will pop up on your test, also pop up on your EOC, and I'm going to show you where they might pop up in your future. So I'm going to show you that first and foremost. Alright, so where this might pop up in your future, if you look at this, alright, this probably makes no sense to any of you guys, and it shouldn't. Okay, I don't want you to read any of this. I'm just showing you that in the future, this is something I'm doing with my ACT prep class. Hopefully you guys know what the ACT test is, but it's a college acceptance test. How you do on it can determine the college you get into. But if you look on here, all right, you should hopefully know that these are graphs. Right? They're not the kind of graphs we're going to talk about. We're going to talk about speed and acceleration graphs, but the principles will still apply. So if you can learn how to read these bad boys, or if you can learn how to read the ones I'm going to teach you today, then you should be able to take that same knowledge and apply it to the ACT, and it will help you when you take your ACT science test because you know how to look at graphs and analyze data. Okay, so these are the kind of graphs we are going to look at. Motion graphs. So hopefully you picked up the packet off the end of the table as you came in this morning. If you didn't, go ahead and pick that up. But we're going to look at two kind of motion graphs. First kind is a distance time graph. Right? So, you look at this graph, which is on the front page of your packet. Alright, you need to know your two axes. Alright, so you have the y and the x. I'll give you a second so you can figure out what those are. So hopefully you know that the up and down axis is the y, and the left and right is time. Right? And notice what's on our x-axis. It's time. What's on our y is distance. Okay? So you should know if we have distance and time, we can figure out something we know an equation for. Alright? So if you have distance and time, you can figure out the speed. Right? Same thing with the triangle. You got distance, you got time. That lets us figure out the speed. So I'm going to erase all this in just a second and scroll down. Because there's no line, there's nothing graphed here. If there was, that would tell us, that line would tell us an object's speed. Alright, so I'm going to erase. Okay, so I erase everything. And feel free to write on these guys as we are going. Alright. And some spots on yours, on your packet, may have places where things need to be filled in. And I'll kind of help you guys fill them in. I may ask you questions and let you fill them in, and then tell you the answers later. Okay, so this time we still have distance and time. So that means this graph is telling us speed. Alright, but as we look, okay, time is increasing, right? So if I had some time on here, like 2 seconds, 5 seconds, 10 seconds, alright, the time is increasing. But what's happening to this person's distance? Alright, so here would be 0, maybe this is 5, 10, 15 meters. Alright, well, it looks like they're staying at 5 meters. So, time is increasing. The person's not going anywhere, so they are at rest. So if their distance isn't going up, then they're at rest. we're going to flip to the next page. Alright, so we flip the page over, looking at the first graph right here on the next page. Okay, so this time, the distance is doing what? Well, it's increasing, and the time is increasing. So now we know that this object is moving. If it's moving in a relatively straight line, we say that speed is constant. A straight line on a speed time graph, or distance time graph, is a constant speed. So this guy's not speeding up, not slowing down. They're going the same speed all the way to the end. Alright, now look at the graph right below that. Still distance and time, so that means both lines are showing us what? Showing us a speed. Alright, well, let's compare the two speeds. Okay? Since both of them are straight, not curved at all, since they're both constant, well, I want you to tell me which one is moving at a higher speed. Is it the dotted line or the solid line? So to figure that out, we need to look at the slope. So the slope, guys, is how steep it is. Alright? So the steeper the line, meaning the more straight up and down it is, so this line is steeper than the one below it. So let's say I pick a spot on here. I want to know how long it takes them both to go. Let's say this is 10 meters. Alright, well, they're both going to get to 10 meters eventually. This one's going to do it in about half the time. So that means the dotted line has a higher speed. It's going the same distance in a shorter amount of time. So the dotted line has a higher speed. So the steeper line, which is the dotted line, has a higher speed. Okay, so let's look at the very bottom graph now. And let's see if we can figure out what this line is showing. So here we have a constant speed. Then we hit about here, something happens to our speed. Alright, so if it's getting steeper, what is happening to our speed? Well, if it's getting steeper, that means, well, is speed going up, going down? Well, it's easy, it's going up. Speed is increasing. Alright, what do we call that when something's speed increases? What's the right vocabulary? Well, it should be pretty easy to do. We say the object is accelerating, it's getting faster, right? Alright, so flip your page. You're going to look at a little summary here, make sure we understood our distance time graph. So if we have distance and time on a graph, remember that tells us speed. So on your graph, you've got some little lines there, some little arrows. We're going to see if we can, I'll actually label these. Alright, so I have some little labels, maybe make it a little easier. So this is line A, B, C, D, and E. Alright, so I want you guys to describe your words, write it on your paper, what is happening at each of these spots. That would be a good time to pause the video, take a minute, look at it, figure out what you think is happening, and then come back and check here in just a second. So go ahead and pause and press play. Alright, so since line A is going up, but it's a straight line, we would say this is a constant speed, but it's the highest slope, so this is a pretty fast constant speed. Alright, line B starts out not real fast, but then the slope is increasing. Alright, so that means this line is accelerating. Alright, line C, this bottom line here, well, it's steady, constant, except it's slow, right? So it's constant and it's slow. Alright, and then line D, well, the time is increasing here. What's happening to the distance? Well, the distance has stopped moving. It's not increasing. So So this guy would say not moving. So D, object's not moving. Alright, then E is probably the hardest one to understand. Alright, so let's say here, I'm going to pause and erase some stuff. Alright, so that's a little easy to understand. So E right here, alright, starts here. Okay, so let's say their distance is, let's say each cube represents 5. So their distance is 12.5 meters away from where they started. Alright, well at this point, what are they doing now? Well, now they're back at 0. So it looks like now they're back where they started. So they're not actually slowing down. Their distance is actually decreasing. So they're going back to wherever it was they came from. Decreasing speed would look more like this. Slope that's getting less. That would be slowing down. Alright, flip the page over again. Should have some graphs you can look at, 4 of them. Go ahead and answer this question, which shows the runner started 10 yards ahead of the other. Maybe write an explanation. And then after you answer that one, flip your page again. Alright, question says, which of the following graphs are both runners moving at the same speed? Alright, so do the same thing. Let's look at the 4 graphs. Write your answer, A, B, C, D, and explain it. Maybe with one sentence. Alright, so which one shows runners starting 10 yards further ahead of another? Well, it looks like A would be our best answer because this guy starts at 0. So you're starting on the left, starts 10 yards ahead. These guys start 20 yards apart. They start at the same place. They start at the same place. So A is your best answer. Alright, and this one, which one are they moving at the same speed? So to know the speed, you need to look at the lines and their slopes. You want them to be the same. So it looks like the ones with the slopes are the same is D. One way you know that is this person goes from 20 to 10, and it takes them 4 seconds. This person goes from 10 to 20, so they're both traveling 10 meters. They're both doing it in 4 seconds. So her speed is distance, 10 meters, divided by time, 4 seconds. So that's the exact same speed for both. And it's the same speed. Alright, turn your page one more time. And what you need to do is take the descriptions up here at the top. So description 1, car stopped. 2, car is traveling constant speed. 3, speed is decreasing. 4, car is coming back. Alright. See if you can match those. 1, 2, 3, and 4 with the graphs down here at the bottom. Alright, so graph A goes with which number? Alright, so that's where you'll match your description number. And then Y. Alright, so graph A matches number whatever because this. Okay, so that's what you're doing. So maybe pause video for a minute so you can figure out which graph goes with which description. Then I'll go over it here in just a second. Alright, let's go back up here to the top. So, car is stopped. Well, that's where distance is not changing. The only one where distance stays the same is right here. So C matches up with 1. Traveling at a constant speed, remember that's where the line stays exactly the same. So it looks like this one is a constant speed. Decreasing speed, well that's where you slope up and then back down, because you're slowing down. So that would be that guy. And then car coming back, well that's where if you started here, alright, when are you getting closer to there? Well, this one's getting closer. They're not back where they started, but they're getting closer to back where they started. That is that.